Multitrack recording revolution. The 1970s saw a widespread adoption of multitrack recording techniques, which had been pioneered in the 60s. Recording studios began to invest in multitrack tape machines with 16 or even 24 tracks, allowing for greater flexibility and creativity in the recording process. This enabled artists and producers to layer multiple instruments and vocals independently, facilitating the creation of more complex and polished productions. Analog tape machines. Analog tape remained the dominant recording medium during the 1970s, with reel-to-reel tape machines being the primary tools for recording and mixing. The decade saw improvements in tape machine technology, with advancements in noise reduction systems, tape formulations, and transport mechanisms contributing to better sound quality and reliability. Noise reduction systems. Noise reduction systems such as Dolby NR, noise reduction, and DBX were introduced to reduce tape hiss and improve the signal-to-noise ratio of recordings. These systems use dynamic noise reduction techniques to encode and decode audio signals, effectively reducing the level of background noise during recording and playback. Tape formulations. Tape formulations continued to improve in the 1970s, with manufacturers developing new formulations that offered better frequency response, higher output levels, and increased durability. Improved oxide coatings and binder formulations resulted in tape with lower print-through, better storage stability, and longer archival life. Console technology. Mixing consoles became more sophisticated in the 1970s with the introduction of larger consoles featuring more channels, improved routing options, and built-in EQ and effects. Solid-state electronics began to replace vacuum tubes in console designs, offering greater reliability and efficiency. Increased channel count. Mixing consoles in the 1970s saw a notable increase in channel count, with larger consoles offering more input channels for connecting microphones, instruments, and playback devices. Consoles with 16, 24, or even 32 channels became common in professional recording studios, allowing engineers to accommodate larger ensembles and more complex recording setups. Improved signal routing. The routing capabilities of mixing consoles improved in the 1970s, with consoles featuring more flexible signal routing options. Engineers could route signals to multiple buses, groups, or auxiliary sends for parallel processing, submixing, and effects processing. Matrix routing systems also became more prevalent, allowing for complex signal routing configurations and headphone mixes. EQ and filtering. Mixing consoles in the 1970s featured more sophisticated EQ and filtering capabilities compared to earlier designs. Parametric EQ, which allowed engineers to adjust the frequency, the bandwidth, and the gain of individual EQ bands, became increasingly common. High-pass and low-pass filters were also integrated into many consoles, allowing engineers to remove unwanted low-frequency rumble and high-frequency noise from recordings. Monitor section enhancements. The monitor sections of mixing consoles were improved by the 1970s to provide engineers with more accurate monitoring and control over the audio signal. Consoles featured dedicated monitor outputs, headphone amplifiers, and speaker switching capabilities, allowing engineers to monitor different mixes, cue signals, and reference tracks with ease. Automation systems. Automation systems began to appear in mixing consoles in the 1970s, allowing engineers to automate the mixing process and recall complex settings. Motorized faders, tape-based automation systems, and computerized automation systems allowed engineers to program and recall mix moves automatically, increasing efficiency and repeatability in mixing workflows. Integrated metering. Mixing consoles in the 1970s often featured integrating metering systems to provide engineers with visual feedback on signal levels and dynamics. VU meters, LED meters, and peak meters were commonly integrated into channel strips and master sections, allowing engineers to monitor signal levels and avoid clipping and distortion. Effects processors. The 1970s saw the proliferation of effects processors in recording studios. Analog effects such as reverb, delay, and chorus became standard tools for shaping the sounds of recordings. Innovations in effects technologies such as digital reverberation and phase-shifting effects also emerged towards the end of the decade. Digital effects in the 1970s marked the early stages of digital signal processing, DSP, in audio production. While digital technology was still in its infancy, several key developments laid the groundwork for digital effects processors that would become ubiquitous in the following decades. Pitch shifters and harmonizers. The late 1970s saw the introduction of early digital pitch shifter and harmonizer units. These devices allowed engineers to shift the pitch of incoming audio signals up or down by predetermined interval, creating harmonies and musical effects. Digital reverb units. The first digital reverb units emerged in the late 1970s, offering more realistic and versatile reverberation effects compared to traditional mechanical reverbs and spring reverbs. These early digital reverbs utilized convolution and algorithmic processing techniques to simulate the acoustics of different physical spaces such as halls, rooms, and chambers. The Eventide H910 Harmonizer. One of the earliest digital effects processors, the Eventide H910 Harmonizer was introduced in 1974. It was primarily designed as a pitch shifter and harmonizer, but also offered delay and modulation effects. The H910 used digital signal processing techniques to manipulate audio in real time, paving the way for future digital effects units. The Lexicon Digital Reverb. Lexicon introduced its first digital reverberation unit, the Lexicon 224, in 1978. It utilized early digital signal processing algorithms to generate realistic reverb units, offering greater flexibility and control compared to analog reverbs. The Lexicon 224 quickly became a staple in recording studios, setting the standard for digital reverb effects. Commercialization and adoption. While digital effects processing technology was still relatively expensive and limited in availability in the 1970s, several companies began to commercialize and market digital effects units to recording studios, broadcast facilities, and live sound venues. Manufacturers like Eventide and Lexicon first introduced some of the first commercial digital effects processors in the late 1970s, laying the groundwork for widespread adoption of digital effects and technology in the following decades. Synthesizers and electronic instruments. Electronic instruments, particularly synthesizers, gained popularity in the 1970s, shaping the sound of music across genres. Analog synthesizers such as the Moog modular synthesizer and the ARP 2600 became widely used in recording studios, adding new textures and timbres to recordings. Analog synthesizers. Analog synthesizers continued to evolve and proliferate in the 1970s, with several iconic models introduced into this period. Companies like Moog Music, ARP Instruments, and Roland released synthesizers that became synonymous with the sound of the era. These synthesizers featured analog circuitry to generate and shape sound, offering a wide range of sonic possibilities, including rich basses, lush pads, and soaring leads. Polyphonic synthesizers. The 1970s saw the introduction of polyphonic synthesizers, which could play multiple notes or voices simultaneously. Models like the Moog Polymoog, ARP Omni, and Sequential Circuits Prophet 5 were among the first commercially available polyphonic synthesizers, offering musicians the ability to play chords and complex musical arrangements. Polyphonic synthesizers expanded the expressive capabilities of electronic music and became popular tools in recording studios and live performances. Digital synthesis. The 1970s saw the emergence of digital synthesis techniques, paving the way for new types of synthesizers and sound generation methods. Companies like Yamaha introduced the early digital synthesizers such as the Yamaha GX1 and the CS80, which combined analog and digital technologies to produce unique and expressive sounds. Digital synthesis techniques, including frequency modulation synthesis and wavetable synthesis, would later become central to the development of digital synthesizers in the 1980s. Portable synthesizers. The 1970s saw the development of portable and compact synthesizers that were more affordable and accessible to musicians. Companies like Roland introduced compact synthesizers such as the Roland SH1000 and the SH2000, which offered basic synthesis capabilities in a portable package. These portable synthesizers helped democratize electronic music and contributed to its growing popularity in mainstream music. MIDI standardization. Towards the end of the decade, the Music Instrument Digital Interface standard was developed, laying the foundation for digital music production. MIDI allowed electronic music instruments such as synthesizers and drum machines to communicate with each other and with computers, enabling the creation of complex arrangements and compositions. Digital recording emergence. While analog tape remained dominant, the 1970s saw the emergence of digital recording technology. Early digital recording systems such as the 3M Digital Audio Mastering System and the SoundStream Digital Recorder offered improved sound quality and editing capabilities compared to analog tape. However, these systems were expensive and not widely adopted until the following decade.